Hi ladies, this is a continuation of lesson 4.2. It's about graphing quadratic functions in vertex or intercept form. We left off with intercept form, and this is a part where we can use our graphing calculator. So I'm just going to show you a few quick little tricks with your calculator to find the intercepts or the maximum or the minimum. So the example is that although a football field appears to be flat, its surface actually is shaped like a parabola so that the rain runs off either side. The cross-section of the field with the synthetic turf can be modeled by this equation, y equals negative 0.000234 times x minus 80 squared plus 1.5. X and y are measured in feet. The question is, what's the field's width? So that's the first question, what's the field's width? And then secondly, it's what is the maximum height of the field surface? So let's start by putting this into our calculator. So you're going to clear out your calculator and go to y equals, and then you'll plug in this equation. So negative 0.000234 times the group x minus 80 squared plus 1.5. Now you might have to adjust your window a little bit. Here's my window settings, negative 100, 200 for x. I have a scale of 10, so that's like how many, each dash is going to be 10 units. And then my y minimum is negative 5, my y maximum is 5. So if you want to change your units to this, that should work, but otherwise you might have to play around with them for a little bit to get your whole graph in the picture. And then you can graph it, and you should get a parabola. So since we're working with intercept form, let's first find our intercepts. So to do that, go to second calc, it's right above the trace button, and we're looking for the zeros. So number 2. And then it asks you for your left bound right here in black letters. You can see left bound. So scroll over till you're on the left-hand side of your first 0, and then hit enter. And then it'll ask you for the right bound. Okay, then you can calculate that, and we get negative 0.064. So that's our p value. P is negative 0.064. Now let's find our q, because p and our q are our x-intercepts. So again, go to second calc, 0, and it'll ask you for the left bound, so you'll go to the left-hand side of your next 0, and you can be as close or as far away as you want. It doesn't really matter. And then it'll ask you for your right bound. Okay, and then it puts it right at your x-axis. So then our x is 160.06, so that's our q value. So I'm just rounding to the nearest hundredths, that's enough. Okay, so now that we have our p and our q, we can find our width. Our width is going to be, our width is going to be of this parabola. I'm going to put it in the notebook here for a second. Oops. So of this parabola, we're looking for this width right here. So the time the field is at 0, all the way until it's at 0 again. Okay, and then this whole part here, that's the field. But anything below the ground, that's not field at all. It's just the part that's above the ground, which is the part that's above the y equals 0 line or above the x-axis. Okay, so if we were looking for the field, we're looking for the distance between here and here. So we're going to take 160.06 minus 0.064. Well, actually, here I rounded to thousandths, so I should round to thousandths here too. Or hundredths both places. Just be consistent, otherwise you're going to get an inaccurate answer. Okay, so 160.064, gotta quit out here, minus minus a negative 0.064. So 160 minus negative 0.064, which is plus. That gives me a field width of 160.128, and it says it's measured in feet. Okay, now the second question is looking for the maximum height. So that, again, we can do on our calculator. So we'll go back to our graph and go to second calc, and we want to find the maximum. So it's going to ask us for a left bound again. And so you'll just go to the left-hand side of the vertex, and then it'll ask you for the right bound. And so you have to go to the right-hand side of the vertex. And then it'll give you the maximum, 79.9999986. So we're going to round that to 80. And that's for your x-axis, your x-coordinate. So when we're looking at maximum height, so this is our x-coordinate of our vertex, that's right here. That's saying that 80 feet from the sidelines is where our maximum height is, which makes sense because our whole thing is 160 feet. So 80 feet from the sidelines is where our maximum height is. And now our actual height off the surface is 1.5 feet. All right, so be careful again when you're reading these story problems to answer the exact question that it's asking. All right, so again, just make sure that you're answering the question that it asks you. So here our maximum height is 1.5 feet. So the maximum height of the field surface, 1.5 feet. Now, you could also find the x-coordinate of the vertex by taking p minus q divided by 2. So here we would have negative, quit out of here, we would have negative 0.064 minus, or plus q, p plus q divided by 2, plus 160 and divide that by 2, and we would get 80. So 80 is our x-coordinate. So if we substituted in 80 for x, 80 minus 80, which is 0, squared, plus 1.5, we'll get 1.5, exactly. Okay, so whether you do it in the whole thing in your calculator and find the vertex that way, or if you just find your P and your Q using your calculator, either one of those will work. You will get a vertex of x-coordinate 80, y-coordinate 1.5. Okay, now the next part is forms of the quadratic equation. We've got standard form, vertex form, and intercept form. So just to put this all in one place and so you can see it all organized, your standard form is y equals a squared, oops, not a squared, ax squared plus bx plus c. The x-coordinate of the vertex is negative b over 2a, and the axis of symmetry is your x-coordinate, which is negative b over 2a. The vertex form, so again, this is the one that kind of looks like the absolute value. So your vertex form is you still have an A, but now it's times x minus h squared plus k. The vertex is h, k. H is your x coordinate, k is your y coordinate. The axis of symmetry is still the x coordinate of your vertex. So x equals h. And then lastly, our intercept form. That's y equals a times x minus p times x minus q. And the x-intercepts are p and q. And the axis of symmetry is halfway between p0 and q0. So that's p plus q divided by 2. So then lastly, all forms of the graph open up if a is greater than 0. So it opens up if a is greater than 0, so it looks like this. So that means you have a minimum. And they open down if a is less than 0. So it looks like this. So you have a maximum. And the minimum and maximum are the y coordinates of your vertex. So please check on any questions you have from this lesson, and we can go through them together when I see you in class. Thanks.